Hey, welcome to the second video in the series on probability for the middle school's national curriculum program. Have a look around the screen here. What do you actually remember about probability? Anything? What do you remember here? Well, let's go back up the top here to the little spinner. That was the on the first screen in the first video on probability, and we counted up all the yellow possibilities here, all three of them, and we said we had a chance of 3 out of 8 of that spinner landing on a yellow. 3 out of 8 because there were 8 different possibilities there. Do you remember that? So a lot of this video is revision stuff of what we've done before in the first video. So it'll take you along the journey a bit, but with a few harder problems and a few new things. Okay, so come over here. What about this? This was our line representing all the possible probabilities. And here we are. What's the probability of rolling a total of 14 on 2 dice? Well, you can't, can you? It's impossible because the maximum on any die is a 6. What about the probability of tossing a head when you toss a coin? Well, that's an even chance, 50-50 or 1 in 2. And what about the sun rising tomorrow? That's a certainty. So we have probabilities going from 0 to 1. And they are fractions generally now. So many chances out of the total. That's what we were doing in that first video. And what about coming down the bottom left here? What about a bag of marbles? What's the probability of getting a blue? Well, let's have a look. There are 2 blues out of a total of 5 different marbles. If they're all the same size and we don't look, it's selecting at random, in other words, equal possibility of picking out any one, it will be 2/5. Now here's something new. Who's been doing something here? It looks like some sort of diagram to work out all the possible outcomes. When you toss a coin twice, you could have a head or a tail. So we'll start the experiment here. And, well, they haven't put it in here. This is the result of the first toss. You could get a head or a tail. Then on the second toss, the overall outcome, if there's another head, would have been a head and a head. Down here, head and a tail, or a tail and a head, or a tail and a tail. Okay, let's just go back there. And so that's a way of working out your sample space, isn't it? All the possible outcomes. You remember that word, sample space, the space containing all the possibilities. And when we do an experiment, we take a sample from there. Maybe it's this one comes up, 2 tails. Okay, that's interesting. Looks a bit like a tree, doesn't it? And we'll have a look at that way of analysing our sample space a bit later on. And here's a diagram that we looked at in the last presentation, and it's enlarged a bit and some other information's on it. Now, do you remember this one? It's the sum of the results on 2 dice, adding them up. And here we go. What's the chances of getting a 2? You can't get lower than a 2, can you, when you roll 2 dice, because the lowest number on each one is 1. So that could be done like that, 1 and a 1. How would you get a 3? You could have a 1 on one die and a 2 on the other, or a 2 on one and a 1 on the other. Oh, hang on, we keep pressing the screen too hard here. So there are 2 ways of getting a 3. That's what this number up here is. The number of ways you can get that total on the 2 dice. And a 4, you could get with a 1 and a 3 and a 1, or a 2 and a 2. So there are 3 ways of getting a 4. There it is there. Okay, so that's interesting. What are they doing here? They're working out the percentage probability of getting a sum less than or equal to 4. So all of these, what's the probability of getting one of those? Well, let's add them up. there are, what are there? 6, 3 plus 2 plus 1, 6 chances out of, now, when you roll 2 dice, what are all the possible sums you can have? They're along the bottom here. How many ways can you get them? Well, this is the number of ways up here, up this top side here. So if you added up all of them, adding up how many ways you can get that one, that one, that one, that one, that one, that one, that one. You might do this later and have a look. There are actually 36 different ways of getting sums of the nature here that we've got along here. So 6 out of 36. That's interesting. There's something else which is interesting here as well. If you go down the middle here, there is symmetry, isn't there? One side is identical to the other. Now that's interesting. And so we've got up here a percentage probability equal to this one for the symmetrical position on the other side. Wow. We'll have to think about that later on. I would just want to go back and have a look at why did they go to percentages? Why not change? Why not just leave it at 6 out of 36? Do you remember what percentages are? Well, first of all, how do you do it? 6 out of 36. Percent means per 100. So we'll find that fraction of 100. And that's where we get 16.6 recurring, or approximately 16.7%. So I suppose you can do that, changing fractions to percentages by timesing by 100. You want percent per 100. But why do we do it? I'll just scrub this out again. And do you remember some of your more junior maths? Let's say you wanted to compare two numbers, something like, I don't know, what could we do? 3 out of 20, that probability, with something like 4 out of 25. What about comparing those two? Okay, they're out of different things, so it's very hard to say what's going to go on there. So let's make them out of 100 then. Percents. Let's make percents. So I'll just do this one first. 3 out of 20 times 100 is doing the same to top and bottom line, keep the balance of the fraction, dividing bottom line by 20, and top line by 20 is 5, so it's 15%. What about the 4 over 25? Multiplying by 100 to make an equivalent amount out of 100, or per 100. 25 into 25 goes once. 25 into 100 goes 4. So 4 times 4 is 16%. So this is a higher probability. So when we've got things like that, we can actually change them to percent to have a common denominator, if you like, or a common value out of 100. Okay. What's this down here? I'm going to take you back now, so you might copy this URL down later. I'm going to take you back to the first video and just remind you about a definition that we had there. So come back with me now and let's have a look at that. Here we go back to YouTube. So here we are, and we'll just wait for it to load here now. There it is. Okay. So do you remember that? That was our,
Hey, welcome to the first in a series of presentations on probability. I hope you enjoy them. What is probability anyway? That's the big question right here in the middle.
And
What is probability?
To, about here, I think.
Sample space
And you
when you
remember
toss one coin.
and a few other things here, but we'll just come along. There's the one that I want. So if we pause that, do you remember that definition? That's about how far we're going to go in this presentation, a bit further, but we're going to go up to that one. So I wonder if you should go back and perhaps look at that sometime. and see what you think. So there's the URL down there, and you can go back and have a look at that, because this video leads on from there. So you should make sure you're up to date with those basic definitions. All right, so let's go to our opening problem to stimulate some thought there. So let's read it together. Maud is interested in finding the probability that a person who enters her store will buy something. That's fair enough. She wants to make a living. One morning she observes 25 people, or better circle that, 25 people entering her store. 9 of the people buy something. 9's going to be important. Okay, things to think about. Can you use this information to estimate the probability that a person entering Maud's store will buy something? Well, I reckon we could do something, couldn't we? Because 9 people out of 25 bought something. So that's a bit of an estimate, isn't it? 9 out of every 25 perhaps is the pattern. We don't know. Now, the next 2, I want you to pause the presentation and discuss it with your teacher and classmates. How accurate is the estimate? How can the accuracy of the estimate be improved? All right, well, pause it and discuss it. There's a few things you might think about. Okay, let's come back and talk about it. How accurate is the estimate? Okay, we'd say probably not very. Is that what you thought? Well, why isn't it? Well, it was only one day. Okay, one day. Only one day. And that doesn't represent what? All the possible days of the year when she would be selling stuff. It could be a different day. It could be in the summer, the winter. So you should actually, probably answering this, to get a better estimate, take more days and spread them through the week and through the seasons. Maybe year by year, but it depends on how much time you've got to come up with this estimate. But certainly, one day like that can't be enough to represent all the possible variation there might be in her selling. Okay, so did you get it? We're going to be doing that, the idea of sampling, of taking many different situations to cover the possibilities. Okay, let's go and have a look at our number line again. Now, last time you saw this was in the last presentation, we were talking about English language and where that would land us on the probability scale. But now we're going to use mathematical language. So down this end, impossible, in this batch, around there, if you want to know the best math language to use, would be very unlikely to happen. In the middle, not likely because it's on the bottom half, slightly less than even. So if it's around here, that's the way we would generally describe it in Mathland. Even chance is in the middle, 50-50 or 0.5. And then on the other side, slightly more than even. So that's how we're going to describe these sectors of our number line. It's likely to happen in there and very likely to happen up the top and certain in there. So if you had 90%, you'd call it very likely to happen, something in that range there. Okay, so here we are. I hope you took the notes down from the first video. The probability of an event is a measure of the chance or likelihood. Remember, 3 were yellow out of 8 sectors on that first page. An impossible event has 0% chance, so impossible can't happen. And a certain event has 100% chance. And all the others are fractions, between 0 and 1. Why are they fractions? Because it's a number of possibilities that you're looking for, your event if you like, out of the total. Okay, so it's all going to always be less than 1. It could be 1 if you'll settle for any of the outcomes. All right, let's go on now. Let's do an example and see if you're any good at this stuff. Using a number line, we're going to describe this event as a 75% chance. So where is 75%? 75% is here. So it's in the likely to happen range there. What about 40%? Let's find 40%. It's a little bit less than 50-50 or 0.5. So we're going to use those words there. So the first one, 75%, is in a likely, and the other one slightly less than even. Okay, so that's the language we're going to use now to take away interpretations, different interpretations that people might have with the words and where the probability lies on the number line. Okay, let's go on. Here's some exercises for you based on that. So here's your set of exercises, and what I'd like you to do is to pause the presentation now and have a go. And you can toggle forward and look at the answers in a minute, but only look at the answer to the question that you've done. Possibly do one or two and make sure you're getting them right before going on and doing the whole lot, and perhaps making the same error over and over, so don't do that. All right, pause it and have a go. Here are your answers now, and I hope you're getting some right there. Okay, now just remember, we're going to use this language now. Okay, I want you to use those words, not your own, because these are accepted maths language where other maths students will know exactly what you mean if we use common language. All right, let's go on. Okay, so here's some more definitions. The outcome of an experiment. As I mentioned in the last video, the outcome is what comes out of rolling the die, which we call an experiment, or spinning the spinner, or taking a block out of a box. And it's in one trial. A trial of the experiment is when you do it once and see what you get. And then down the bottom here, a sample space is a set of possible outcomes. So just remember what we were doing. We said the sample space was equal to the set of, that means the set of outcomes. So it's 1, 2, 3, 4, or 5. Okay, in this case, and there we have it there. That's a set of possible outcomes. So the sample space, that's important language. People know what we're talking about. So that's the set. And of course, on one trial, we will sample one of these. We'll get one like 4 maybe. And so that's why it's called the sample space, as the trials of the experiment go on. So we'll take samples from that group. All right, let's go on. So here you are. Here's your set of exercises, 15B, down here. And I'd like you to pause the presentation and have a go at those. Okay, let's have a look at the answers. There they are, 15B. I hope you are going well and getting the hang of it. I'd like you to use S equals and then the curly bracket, S standing for sample space. Moving on. Right, more definitions. Okay, so here we are. An event occurs when we obtain an outcome with a particular property. So it's one of the outcomes that we're looking for, particular property. Okay, so I hope you've written these down. If you haven't, do it now. And then this is where I just showed you we got to in the last video, the probability. And remember, we said in that video we'd use PR, because P can mean other things in maths. PR, the probability of event, is a number of outcomes corresponding to E. So we might, up here, have a look at this. We might want an even. So the probability of an even is the number of times it occurs here. So what is it? 2, 4, 6, and 8. So that's 4 out of the total 8. Okay, so 4 out of 8. And that's the bottom line, of course, the total number of possible outcomes, or the total number of items in the sample space, if you like. Okay. All right, so here's an example to show you, and then I'm going to get you to do some again. So we've got a spinner again here with this little thing in the middle spinning around. We want the probability of getting a D or a vowel, part A, a D, so where is it? Yeah, there's only 1. And here's our sample space, that's 1 out of 5. Now, the vowel, what's a vowel? A vowel is A, E, I, O, or U from your English study. How many of those have we got there? We've got the A and we've got the E. So there are actually 2 outcomes out of 5. 2 chances of spinning a vowel. Okay, getting the hang of it? I hope you're on top of this now. I think you would be. Okay, so here we are. Time to practice. There's the first 4 problems from exercise 15C. So pause the presentation and have a go. Maybe at the first 2 and check your answers, but don't look on at the other answers. Or if you feel you will, just try all 4 and check them all off at the end. Okay, here we go. So those answers are after some more problems, so you have to toggle ahead if you want to get them at the moment. Example 3, a ticket is randomly selected. Okay, so you're not looking at it. Each one has an equal chance of being included. So they must be the same size and you can't see the colours or anything. Okay, we've got 3 green, 4 yellow, 5 blue. What's the probability of getting a green first of all? Well, we got 3 green and the total and the sample space is 12 tickets. So that's 1 on 4. Okay, what about a green or a yellow? Or here's a key word, or. Now, if you settle for one or the other, you're going to add them up. Okay, 3 green and 4 yellow out of 12. So we've got an association of the word or with addition. Okay, 7 out of 22. You see why you're adding them up, because you'll settle for one or the other. You're making more possibilities. What's the probability of an orange? Well, hang on, there aren't any orange, so it's 0 out of 12, or 0. It can't occur, no chance, impossible. Not even a ticket in there which is orange. What about green, yellow, or blue? So there are 3 possibilities. So we're going to add up those tickets there and divide by 12, and it's 12 out of 12. In other words, it's a dead certainty because it's got to be one of those colours, and you say, well, I don't care what colour I get, so you've got to win, don't you? You've got to get what you want. It's got to be one of those colours. That's a certainty. Okay, get the hang of it. Let's do some more problems. Here we are, down to question 12 here, and then we'll finally look at the answers. So these problems you can work through, pause the presentation. I've got one more on a page by itself because I want to talk to you about it. Okay, because it does show you what use probability can be in a little way. Okay, so pause it and have a go at those. And here's the problem that I'd like to show you, the layout of seats on an aeroplane. Okay, and this is a real life situation. You go up or online and ask to book a ticket. They will give you a picture like this, and you can move the cursor and put yourself in a seat that's vacant and make that your booking. Okay, so here the ones that are taken are shaded in red. Okay, so you can't have those, they're already booked. Now you might like to sit in a front row seat, so that's in this section. What's your chances of getting one of those? Now that's if you don't book it, you know, it's yourself. You just ring up and say, I want a seat. So it's taking it at random. In other words, they could give you any one of these, but you want this one up in the front section. What's your chances? A seat in the emergency row in here, because there's more space there, more foot space in front of you. A window seat, because you want to look out the window. How many seats are there next to a window? What about an aisle seat? An aisle, if you don't know, is the gap there and there. So if you want an aisle seat, then what that means is you don't have to push past somebody else to get into the aisle to go to the toilet or something like that. Okay, so you have to be careful with your counting up. Make sure you cover all possibilities there. Okay, so pause the presentation, and this is an important problem because, it is a practical one. Let's put it that way. Okay, pause it and have a go. Here are the answers now. There are the answers. So there are 13 questions, excuse me, and I hope you have done well with that. Okay, well, let's have a final statement here. Stay tuned for the next exciting instalment. It's the new work, so this is what we've done on a previous presentation, and what the next presentation is about is something you haven't seen before, and finishes off, if you like, the Year 8 part of the curriculum, and then we're going to have presentations on Year 9 and 10 as well. So cheers for now.